So here is the process for comparing segments. All right, if I have two different segments, so again, if you're doing this as well, then you might not have the same two as I have. But if you're comparing two segments, the way that you'll do that is you'll simply take your compass, you'll place the tip of your compass on one end point of your segment, you'll extend your compass out so that it marks the furthest end of that segment. And I expect to see this mark. So even though I do understand that you could adjust your compass without having to leave a mark. So you can still adjust it without drawing your arc in there. But if you're doing this and you're turning it in, I expect to see this marking to show that you marked off the length of that segment. Okay? The second part to this, once you set your compass to the radius measure that's equivalent to the length of one segment, you're just going to move that compass to the other segment, and you're going to construct an arc on that other segment. And then you're going to see, does that arc cross the segment? If it does, then the original segment is shorter than the second one. Does it meet at the exact same endpoint? If that's the case, then they're the same length. Or does it do like this one, where it doesn't intersect the segment at all? Then that means that the original one is longer than the second. Okay, so you're just looking at that comparison. As far as that's concerned, if I was giving you this problem and asked, let's say I labeled this X and this Y, and I asked you, demonstrate which of these segments is longer, your answer would be what? Which one's longer? X is longer, and I expect to see these arcs as part of your work. Now, had you started by setting your compass to the measure of Y. Okay, so you'd set your compass to Y, you'd place the tip of your compass on the other endpoint, and then you'd make your mark. Since the mark intersected the second segment, then that means that the first one was shorter. Okay? So it's going to confirm regardless of which one you do first, but I do need to see one of these sets of marks in order for you to get credit on the work of that. CB looks longer. Okay? So if we want to confirm this, again, it doesn't matter which point we start at, but let's just say we're going to start at point B. We adjust our compass so that it is the length of BC. So here's my original. Okay, and so now when I compare it to AD, I'm going to place my compass tip on the other point, construct an arc. Does this arc intersect AD? No, so that means AD is shorter, so our answer would be BC in this case. Any questions about that? Okay. Regardless of the fact that I know you can look at this, you could take a ruler and measure these. Okay. If you wanted full credit for a question like this, which is a basic question, it should be easy, you'll need to have both of these markings. Okay. Otherwise, I'll assume that you used a different method, didn't follow directions. You should do all the same steps that you would to begin duplicating an angle. So you're going to construct an arc that passes through both sides of your angle. You're going to keep your compass the same exact measure, and you're going to construct a corresponding arc between the other angle. So both of those arcs should have the exact same radius. It doesn't matter, it can be any radius measure, totally arbitrary, but it has to be the same on each of them. Okay. Once you do that, you're going to continue with the same steps that you would if you were duplicating this angle. So if I was duplicating angle 1, I'd now measure the distance between these two arc side intersections. So I'm going to do that as well here. I'm going to set my compass so that it measures that distance. So now my compass radius is set to the distance between the arc side intersections. And I'm going to duplicate that. So basically what you're doing is, on this one side of angle 2, we're basically going to duplicate angle 1. And we're going to see, would angle 1 fall in the interior of angle 2 or in its exterior? So when I duplicate that, if I connect this intersection back to the vertex, that will be my duplicated angle 1 here. So is angle 1 smaller or larger than angle 2? So if you look, angle 1 and angle 2 are related in that angle 1 is smaller. It's less than angle 2. So if I was giving you an inequality relationship, that's how you would address it. And now, if I had started with angle 2, once again, if I had tried to take angle 2 and duplicate it, I would adjust my compass so that now it's set to the distance of angle 2. And up here, when I construct my arc, it falls in the exterior. So again, if I were to continue this blue arc out, it would fall in the exterior. So I can see here that, again, confirms angle 2 is larger than what angle 1 is equal to. It may be useful to extend your angle size. Again, the further apart or the wider the radius is when using your compass, the more likely that you're going to be accurate. And so by extending the sides, it makes it easier to measure those differences. And so what we would do is place the compass tip on one of the vertices, construct an arc that passes through both sides of that angle, and we're going to duplicate that mark on our other vertex. And so I'm going to change the color of it here just so we can distinguish it, but there may be some overlap, and that's okay. Okay, but now both this brown and this green arc have the exact same radius. And so basically what I'd be looking at is, can I duplicate angle B onto angle A? So in order to do that, I need to measure the distance between the two arc side intersections of angle B. So here, place the compass tip on one of those arc side intersections, widen the compass to intersect the other arc side intersection. So now my compass radius is set to the distance between these two intersections. And I'm going to duplicate that onto angle A. So I'm going to move my compass tip to the known arc side intersection. And then when I swing my compass, it allows me to see. If I were to duplicate angle B on here, the place where I would pass through is from A to through this point right here. And so I can see here, whether you don't need to draw this point or this line at all, but what you can see is the angle B if superimposed on angle A is going to be what? Larger or smaller? It's larger. And so if this arc here falls outside in the exterior of the angle, then the original one was larger. If this arc had fallen in the interior of the other angle, it would have been smaller. And if they lie on the exact same, obviously they are equal. So which one's larger in this case? The answer would be